Okay, this is the next section in chapter 9, 9.3, the Pythagorean Theorem. This is a slight departure from what we've been doing, although we will use what we've been doing in getting the answer for the problems we will be looking at today. But this is a little bit of trig thrown into this chapter, and you'll see the reason why here in a little bit. But we're looking at right triangles, and we're looking at the Pythagorean Theorem. Now, in a right triangle, we need to look at the parts. The two lines that form the right angle, and notice this box here, that means it's a right angle. These two sides are called the legs. Okay, they form the right angle. They're attached to one another, and they make this right angle here. This side opposite the right angle is called the hypotenuse. The hypotenuse is always the longest side in a right triangle. Okay, so Pythagorean theorem states, in a right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. So if I square A and then I square B, it's going to equal to the square of C. So let's kind of look at that. If let's say A was 2 and B was 4, Pythagorean theorem states if I square A, which would be 4, and I add it to the square of B, which would be 16, that's going to give me the square of C. Okay, so that's going to be C squared. To find out what C is, I would have to take the square root of 20, which we don't know because it's not it's not a rational number. But again, Pythagorean theorem states A squared plus B squared equals C squared. Now let's just use that to solve some problems. Okay, now we're going to find the unknown length. And with all of these, we're going to use A squared plus B squared equals C squared. Now we're going to be finding A, B, and C in these. Okay, so let's look at what we're given and what we have to find. So in this one, remember, here's the right angle. C, the hypotenuse, is always across from the right angle. These are the legs A and B. I'm just going to substitute what I have. So for A, I've got 20, but I've got to square it. I don't know what B is. I'm going to leave it. I know what C is, and that's 25. I'm going to square it. Okay, 20 squared is 400 plus B squared equals 25. I'm sorry. Let's kind of go back. 25 squared is 625. Okay, I'm going to subtract 400 from both sides. I'm solving the equation. B squared equals 225. Take the square root. B is equal to plus or minus 15. Now, the thing is, with these, since we're talking about triangles and lengths, I can't use the negative. So technically, if I solve this equation by itself, it would have a positive and a negative 15 for an answer. But because we're doing when we're doing lengths, we're only dealing with the positive, my answer is positive 15 for B. Okay, let's erase this and let's look at the next one. See if we can do this pretty quickly. I think we can. Good. Next one. I'm looking for A, and again, I'm just going to write the formula. Okay, I'm going to plug in what I know. I don't know A. I'm going to leave A there. B is 12, so 12 squared equals 14 squared. Okay, A squared plus 144 equals 196. Okay, so I just squared this and squared this. Now I'm just solving the equation, 2 steps. I'm going to subtract 144 from both sides. I get A squared equals 52. Okay, so I'm going to take the square root of both sides. A is equal to the square root of 52. Okay, the problem is 52 is an irrational number. We need to see if there is a perfect square that divides into 52. So if we come over here and we do upside down division, I divide 52 by 2, I get 26. Divide 26 by 2, I get 13. 13 goes into 13 one time. Okay, if I take out the pairs, that gives me a perfect square. So 4 goes into 52, 52 13 times. So I'm just going to split this up. That's equal to square root of 4 times the square root of 13. And this is equal to 2 square root of 13. That is simplified. So that's the connection with what we've been doing here. When we get a square root that's irrational, that means it's not a whole number. We need to simplify it the best we can. Okay, let's look at the next one. Okay, here's the right angle. It's a pretty bad square. Okay, I'm looking for C. So this is A. It doesn't matter which one's A and which one's B. You can choose. Not going to change anything. 10 squared plus 24 squared is equal to C squared. Well, 10 squared is 100. Okay, 24 squared is 576. That's equal to C squared. Okay, 576 plus 100 is 676. Now I just need to take the square root of both sides to see what C is. So 676, square root of that, that's going to be 26. It's a whole number. Now it's actually plus and minus 26, but we're only using the positive. So in this case, the answer is 26. Okay, let's do one more. Okay, we're looking for A squared plus B squared equals C squared. A we don't know. B we know, it's 7, so we're going to square it, that's 49. Equals C squared, 25 is C, so if I square it, it's 625. Okay, so I'm going to subtract 49 from both sides. I get A squared equals, now we're going to subtract, it's going to be 6, it's going to be a 7, and that's going to be a 576. Okay, so 576 has a very nice square root. Sorry, didn't mean to do that. If I take the square root of both sides, A is equal to plus or minus 24. But because it's a length, we're only going to take the positive. So A here is equal to 24. Again, we're just substituting into the formula, and we're solving. Most of these are just 2 steps that we're solving when we solve these equations. Let's look at another one. Okay, this is actually the last example, so it's a very brief section. We're just going to see if the sides form a right triangle. And again, we're using our formula, A squared plus B squared equals C squared. Now, if when we place these numbers in the formula, it's true, then they form a right triangle. If it's not true, they do not form a right triangle. So we're going to put in 3 for A, 5 for B, and 7 for C. Now we need to square them, so get 9 plus 25 equals 49. Well, I know that's not true already. 9 plus 25 is 34. 34 does not equal 49. So this is not a right triangle. Okay? Look at the next one. Again, A squared plus B squared equals C squared. A is 15. B is 8. C is 17. Okay, 15 squared is 225. 8 squared is 64. 17 squared is 289. Well, if I add 64 to 225, 4 plus 5 is 9, 6 plus 2 is 8, and then I get 2. 289 is equal to 289. This is a true statement. So this is a right triangle. Okay, so the main thing we're doing today is using the formula A squared plus B squared equals C squared. We call it Pythagorean Theorem. Now, when we get an answer that is irrational, meaning we don't know the square root, we need to simplify it. So we get something like the square root, and I'm just going to go over this again. If I get something like the square root of 72, I need to find a number that goes into the 72. And I happen to know that 36, I need a perfect square that divides into 72. And if you don't know, do upside down division. Okay, when I do that, put 2 into that, I get 36, and I happen to know 36 is a perfect square. Okay, so I would separate that, just as a reminder, into 2 square roots. Now, this I know is 6. I don't know this one, so I'll leave it. Okay, so if you get an answer something that's like this, you need to simplify it and put it in this form. So that's how today connects with what we did yesterday. Okay, but mainly today, a lot of answers you get will be whole numbers. Some you won't have whole numbers and you'll have to simplify. And that's it.